Omer ready? And
I'm ready.
action!
Action.
Okay, so hello again everyone. Today we're going to talk about CI/CD runners, and we decided not to talk specifically about self-hosted runners, but about CI/CD runners in general. So, Omer, let's start with you. What do you think about CI/CD runners? What's the first thing that comes up to your mind when I say CI/CD runners? What do you need to take care of when you think about that?
All right. First of all, it's a great topic. I don't know how did you think about such a great topic? Out of nowhere.
Out of
Okay,
nowhere.
so CI runners. There's the two basic options, right? You can start with the one that you host on your infrastructure, and the other easy one, which I think, well, GitLab has one, GitHub has their own too, right? A lot of SaaS solution would just tell you, just use our shared runners. It's fine. You don't have to install anything. We have the runners ready for you. Click OK and run. I tend to not go for this for a few reasons. One of them is security. When you run on someone else's infrastructure, and that's not AWS, right? It's something that's shared. It's literally, that's the name in GitLab. It's a shared runner. You're not really sure how the workspace is being cleaned up, what happens with environment variables, especially if you share secrets. A lot of time you share secrets kind of using the CI server as your secret manager. I mean, a lot of times you have variables stored in the CI server just because you deploy to Kubernetes or ECS or somewhere on your cloud provider. So you have sensitive stuff stored there. Once you store sensitive stuff on the server and you use a runner, things are being sent to the runner. I don't know what's happening there. Is the disk being cleaned? Maybe someone can dump the cache and see my memory. So I prefer not to. So that's the first reason not to do it, is a security reason. The other one is you're a lot of times, mainly if you're not paying for that, you're in the queue. And being in the queue means that you sometimes can find yourself waiting for runners. If you have, like me, a very distributed set of pipelines across your workload, you can find yourself trying to run 30, 40, sometimes parallel runners and being hit with the capacity, because you can get one or two or three. And if you're not built to accommodate that, you're kind of stuck and you can find yourself waiting long, even minutes. Sometimes I waited 30, 40 minutes. Not fun.
Okay, so so you referred to shared runners, cloud runners, okay, whatever we call it. Let's keep it cloud runners and shared runners. I hope we won't mix between the two. Let's try shared runners, okay? Let's try to keep it with that.
All right.
Okay, so shared runners are cloud provider runners, and the other ones are self-hosted runners, okay? The ones that we host ourselves. So for
Cloud
example,
provider, you mean CI provider, right?
CI provider, yeah. It
Yeah.
also can be GitHub Actions runners. I also
Right.
mean these are those shared
Right.
runners, okay?
Yes.
And we can have those self-hosted runners, and those are also two types, I think. The ones in the cloud, right? Because you can have your own infrastructure and spawn EC2 instances or any virtual machines, and then install the agents of the runners of whatever CI/CD service you use.
Yes.
And then use a self-hosted runner in the cloud. Or you can also have on-premise runners. For example, if you have a Windows machine that needs to sign, you love those Windows machines. So if you have a Windows machine that needs to sign artifacts, right? Like with EV signing, then you have to do it on your on-premise machines.
Look, back in 2015, we wanted to build Mac artifacts. We're building an iOS version of a mobile application, and there wasn't a good solution. Maybe Circle CI were the only ones. Anyway, we're not users. I had to build for Mac. You need Xcode to build for Mac. And we literally had a Mac 15-inch sitting on a table in the office, and that was our CI runner for our Mac build. So yeah, sometimes you need that. I know today almost every cloud provider offers you, for example, a Mac version of the CI runner and a Windows for sure. So yeah, sometimes you do need your own architecture for lots of reasons.
But that also depends. First of all, I'll tell you a secret. It's not so bad to put a Mac in the office. So if you have a spare Mac in the office, which might happen. Okay, might happen.
Might
So you
happen,
can
yeah.
use it as a runner. It really depends. You can also use the Mac in the office to sign artifacts like applications. We're talking
But
about native applications.
yeah, but then again, you have an open computer, probably unlocked, it's being used
Yeah.
as a runner, just sitting out there in the office. Anyone grabbing that thing and dumping the memory can see every variable and secret you've shared.
Yeah.
So why even risk it? I mean, if there is a reason, fine. If not, I mean, the cloud is infinite. I can scale to whatever scale I want.
As we always say, it depends. So I think only until recently, like I think only in 2018, 2019, AWS provided the Mac solution in the cloud, and also it was back then. I think it was very expensive, and I think only now maybe the prices are reasonable. So again, it really depends on your needs. So it might be very cost effective to just use a Mac in the office to run your builds than taking a Mac in the cloud. Also, if you build native applications, so caching with Xcode on an existing machine than running it on a machine on the cloud is very different. So it's easier to debug and fix stuff in the pipeline if the machine is actually in the office. I know it might sound weird, but that can also happen.
It's not. It makes a lot of sense. So, like you said, again, in the context.
It depends.
Right? Yeah. And we're really focused around Mac because it's a very special use case with the requirements of Xcode, and it's not very easy to emulate in another environment. So, yes.
Exactly.
But, I mean, 9 times out of 10, you can just do fine with a shared run. Not a shared runner, just a runner that's deployed in the cloud.
See how we skipped those Linux runners. Like we didn't even talk about Linux, right? It was like it was obvious that Linux will probably run, well, not probably, but we will run all the time in the cloud somehow, either by self-hosted runners or shared runners. But we won't have a Linux machine in the office. That's for sure, right?
It's getting complicated when you try to use different architectures. When you want to use an ARM CPU or whatever, Mac, another example. When the architecture changes, you probably want to run on the architecture itself. It's not something you want or can emulate sometimes. So you can kind of cross-compile things to an extent. So I usually just deploy another runner that sits there and wait. We can obviously discuss how we're doing that without wasting too much money. But I'm just deploying different runners for different architectures. We have, in our case, in Zesties, we need to build some type of an agent that sits on top of servers. We need to compile it for different architectures. Customers around the world use different architectures, different operating systems. We need to build for everything. So there's a way to do that. And that's why.
Do you write in Go? Just to know, like, if it's easy. Do you write in Go, the agent?
No, this one isn't written in Go, no.
Okay, so it's more difficult.
It is still, even if you do compile something that compiles into a binary, you still need to compile it for the architecture and the operating system. Even in Go, you need to provide the operating system it's going to run in, and the architecture is being compiled too. A lot of times you try to, I don't think beyond. I mean, if you compile it to the wrong one, you just can't run the binary. You'd get this famous exec error when you run a Go binary that's not fitting the architecture.
But it's so fun to do Go OS, Go Arc, set the architecture, set the operating system, and voila, you got a binary for the exact architecture and operating system. The magic of Go.
Yeah, you can do the same for Docker today with BuildX. If you try using that. So this also kind of a cross-compile tool that helps you build for different architectures and different locations. Yes.
Try using BuildX for Windows.
I know the command. I don't think I will. Just stay away.
Just saying. Okay, try doing that.
Okay, I will.
BuildX, BuildKit.
Maybe we'll just cut this whispering out, so I won't have to deal with the thoughts later. It's gonna hunt me.
Yeah, it's like, don't try this at home.
Yes.
BuildKit on Windows containers
or anywhere. Not at home, not anywhere. Just don't build for Windows.
Yeah. Okay. So let's get back. We always dive deep. To something, and then we need to zoom out and go back to the CI/CD runners. So let's talk about those self-hosted runners in the cloud.
Yes.
How do you usually manage them? How do you like to manage them talking about the infrastructure? So how do you manage self-hosted runners in the cloud when it comes to the infrastructure? Go.
Okay, so let's give context, and everyone's context is going to be different. It's not the same for everyone. My context is I'm not running Kubernetes. And the reason I'm saying I'm not running Kubernetes is because Kubernetes is usually the easiest go-to for anything. It probably has a Helm chart or some kind of package to install on top of it, and being able to scale your runners for whatever system you use. I'm not running Kubernetes, and not only because of that, we're mostly running serverless. I needed the CI system to run and scale as much as I wanted to. I used to be shared runners, and then I looked for something to do the work for me. Again, I'm using GitLab, so I needed something that can speak to GitLab, pull the jobs, run them, but run in my infrastructure. So I found a project. We'll share it here down below. It's written in Terraform, and it's basically deploying a set of, let's call them listeners, that can listen to jobs from GitLab. And those listeners spin up worker nodes as you need them. For every new incoming task, like step in the CI, it will spin up a new node that can run stuff. And it's very configurable. You can decide what's your ideal number of tasks. For example, no job is incoming. The queue is empty. I want to hold at least one or two. So they're instantaneously responding to new incoming jobs. Or maybe that's, for example, the same one with the ARM, right? The ARM chip. So we don't build for the ARM chip every day, maybe once a week, once every 2 weeks. I don't need to keep it alive. I can say that the idle count is 0, but it just waits there. So there is a listener. It's a very small instance, like a T2 micro or something, just sits there and listens for new jobs. And once there's an incoming job, it will provision new node that usually takes a few seconds and let it run. And once it runs, it picks up the job, does whatever it does, and then cleans itself up or just dies. So this is what I'm doing. I'm using it for all of our AWS accounts, all of our environments. Everyone has their dedicated runners, each one with its own configuration. If it's reasonable, I set 0 idle count. If it's not, I'm setting something else. You can even set the time zones, by the way, time zones and working hours. So you can say, I want the runners to leave. I want 10 runners to stay awake from 8 a.m. till 8 p.m. and then go to sleep till the next day. So lots of cool features with that.
Do you do that? Do you use those working runners like according to working times? You know?
Yes. Yeah, I do. I'm keeping one alive at all times. So if there's something really urgent and we can't get anything, it stays there and it's ready. So you have something to work with. But yeah, during working hour, I'll scale them up, especially during like mid-week days. And there's another thing I didn't mention. In my case, you don't have to. It's running on spots. So everything is just provisioning new spot instances. And I'm actually playing with the type of instances. So I'm kind of more flexible in what I run. But the cost is like lower than 40% than it would be if you'd run on demand. So I don't know if it really is less expensive than it would be on Kubernetes. Depends, I think, on the scale and what you run. But it's really nice. It's running on spots. We almost never hit a wall of no available instances or anything like that. So pretty nice.
Okay, cool. So let me share about GitHub Actions Runner Controller.
Yeah, I'm actually interested.
What's the name of the source code? Yeah, so the open source that you talked about, I want to compare between GitLab and GitHub Actions Runner Controller. So do you remember the name?
If you'd Google Terraform, like literally Terraform GitLab runners, you'd find it immediately. While you speak, I'll find it for you.
Okay, good. So I want to talk about GitHub Actions Runner Controller, which is probably similar to what you said, which has this webhook server, and then you can configure the GitHub Actions Runner Controller to listen to the builds according to what? According to new workflow, according to push or maybe pull request or any other Git event, you know. So you can actually, configure it according to whatever you want. The best thing to do is to do it according to the workflow, if I'm not mistaken. I mean, they tell you in the README, in the documentation, they tell you, listen, the recommended way is this, so pick the recommended way. I'm sorry that I don't remember it right now, but I just did it a while ago. And
is it an official solution by GitHub?
No, actually, it's an open source. It's not an official solution, but it has like tons of GitHub stars, it's backed by the community, everybody knows it.
Right.
And I already talked about Carpenter, in our previous session, so it works great with Carpenter. So when the runners scale out, right, when you have multiple runners, so it also scales from 0 to, to whatever you want. And you can also limit it and say, I only want to have 30 runners, for example. So you can have 30 workflows running in parallel, 30
I have a question
jobs.
though.
Sure.
Isn't that kind of an overhead of latency? I'll explain. When I launch a new node, it needs to provision itself, like start up a new Spot instance and then install a few stuff like whatever, GitLab CLI, whatever. Right, it comes with a pre-installed EMI and everything's ready for you, but you need to make some type of connection. In my case, to GitLab, like authenticate against the CI server, tell it, hi, I'm a new runner, let me take this job, I'm valid, I'm fine, I have all the tokens, I'm okay. In your case, it needs to do the same, but also provision itself. Correct me if I'm wrong. Are you provisioning new pods or new nodes for that?
It provisions new nodes, and then you can have those pods on those nodes.
Right. Okay. So what I was thinking is if you need for each pipeline to run a new node, that takes additional time because it has to provision itself as a Kubernetes node and then authenticate with the cluster and then being able to serve the pods for the runners. But it's just you have 2 layers of scaling, right? Like within every orchestrator, it runs new pods, and then when you're out of space, it'll scale up. Okay, good.
Exactly. And usually I do a buffer. Usually, as you said, if I see more jobs coming, so I always have this one, I don't know, like 30%, like with the regular auto scaling for
the
production.
rule of thumb, yes, the easiest one.
Yeah, so like 30% buffer, so there's no way a few developers will hit push and then there won't be any runners available. So I always keep those 30% running, and I actually don't do the working hours thing. I do it only for the nodes, but not for the pods. I just keep the nodes, I keep like 1 at night, but not pods. So runners, I scale them from 0, but the nodes, I scale them all to have only 1 node per runner, as you said, like the type of the runner. So let's say if I have runners that need to run on a node that builds Android, for example, because I love to split my AMIs, so they have those their own Docker images on them and stuff like that, base images. So I keep like 1 of each, and for rare builds, like you said, like about ARM, right? The ARM builds, I don't even keep them. So they scale from 0 to whatever.
Right.
And it's easier to work like that, and without working hours, without nothing. Only the nodes are working for.
But
with the
yeah,
working
again,
hours,
this
not
is the
pods.
amazing benefit of running that on pods on top of a cluster. It's instantaneous. All you're waiting for is maybe you need to pull an image, but this is basically it. The pod is just running.
Yes. Yeah. So it works amazing. So GitHub Actions Runner Controller with Carpenter, already talked about it. It's amazing. And the infrastructure, I maintain it with Kubernetes. Can you guess with which service am I doing it? How am I doing it?
Nope.
I mean, EKS, obviously, right?
Okay, right. Okay.
Yeah, not something. Yeah,
I'm thinking too deep.
It was too easy. Yeah, it was too easy, so I got you confused. Sometimes the question is too easy.
Exactly.
Yeah, you thought I'm trying to be smart, but no, too easy. So I'm using EKS, AWS solution for Kubernetes.
Yeah.
And works great. So you provision the cluster with Terraform, obviously. And then you provision everything regarding Carpenter also in Terraform. It also the configuration for Carpenter, it's also in Terraform.
Yeah.
And the Actions Runner controller, you can deploy it with Helm chart. And then the runners themselves, I use YAML files. It's very easy to do just, kubectl deploy, and that's it.
Sure. Sounds good.
Yeah, apply deployment.
Nice.
Very easy
so
solution.
We've listed the solution for GitLab and for GitHub. Both have shared runners in the cloud. Both have solutions. Both of them actually open source, the ones we mentioned, to deploy things on your infrastructure. I have a tip I think is important to share, and it's a tip that's built on a bad experience I had. So it even started long before I started with the runners for GitLab and everything like that. Specifically when running with container-based CI systems, which is what I use, what you use. Other than Jenkins, I think almost every other solution, most of them at least, are using containers as the base component for the steps, right? Like usually every step is a different container. This usually piles up a load of images and Docker container images that sits on top of your nodes or runners or wherever. And that takes up disk space, whether you mount it from your node in your case, or in my case, just sits on the runner's disk. If you keep something idle for long enough time, it'll just, this space will just empty out because it builds and builds and builds. So my tip is rotate them. Not only for that, for security reasons as well. Again, you're not sure of what's going on. Maybe it's an old version. Maybe someone found a vulnerability in the version of the CI runner that can, again, dump the memory, read the environment, find the keys, find sensitive things you keep there. If you rotate them constantly, you reduce the risk, and you reduce the risk of like getting out of space errors because there's nothing on there's nothing left to save. So that's it. Rotate your runners.
Let's talk about the how. Okay, you talked about the rotation. So let's say, we always like those concrete examples, practical examples. So let's say I'm building a node application, and that node application is built on Docker, as a Docker image. So I'm building and building, and the node machine, the node daemon is full with Docker images, with those old images. So how would you rotate the deletion of those images? Because it's not so easy to decide how to delete Docker images without killing the cache on the machine, right? You want the cache, but you also want to rotate the old images. So how would you deal with that?
Okay, point number 1, don't write a node, yeah? Easier, joking. Point number 2, which is very obvious to me to say, is you can install Zesty's solution and have an infinite disk space that scales up and down with you. But I'll put the marketing pitch aside. So first of all, cleaning containers is as easy as Docker system prune. That command just kills dangling images and provision disks and everything that the Docker agent isn't actually using. But a far easier solution is you're running pods on a cluster. Just kill the pods, or don't keep idle ones for too long. And if you are keeping idle ones because you said you want to keep one alive at all times to serve someone, just have a peak, maybe at night on the least working hours, 3 a.m., just rotate it, kill it, provision a new one. It'll still have the idle component. You can actually do a rolling update if you really care about it, or like a blue-green deployment, just provision a new one, kill the old one so you can keep 100% uptime, but just don't keep them alive. I mean, you can log in SSH, maybe put a cron job, maybe put a job on the cluster that cleans them. I don't see a reason. Just clean your stuff.
Okay, so let's say not everyone can have those sophisticated solutions. Okay, let's say we have I'll take it to the edge, some people are listening and saying, listen, dude, I got those long running EC2 machines and I can't kill them for this and that reasons. Let's not even get to that. But sometimes you cannot just use spot instances because it will take you too much time to migrate to this type of solution. So if you have long running EC2 instances and you want to clean the Docker images from the Docker daemon, how would you tackle that? Let's ask it like this way.
Dirty solution, SSH and clean them. Very dirty.
Cron job. How would you do it with a cron job? Like, what would you do?
Yeah, I would probably run some kind of cleaning command for the agent. Maybe it's not Docker, maybe you're using something else, but the cleaning command for the container runtime agent. That said, that's pretty hacky. You need to SSH, it's not reproducible. Maybe you need to install the creation of the cron job for every new node that comes up. Easier solution, if you're running on Amazon, you have SSM, Systems Manager, and under Systems Manager, there is a small service that's called Run Command, which is a really powerful service that lets you basically run commands on top of instances without doing anything, not SSHing, not nothing. Caveats for that: you need to have the Docker agent, the SSM agent installed, which comes pre-built with any AWS AMI. I mean, if they own the AMI, it's probably there. You can actually see it in the logs and you can tell if it's there or not. And it needs to have the SSM permissions. So just provision runners with SSM permissions to let it communicate with the service, and it runs. And the last caveat is if you're running on what we call a black subnet, as in a private subnet with no NAT on top, no incoming traffic or outgoing traffic, you need to add a VPC endpoint to let it communicate with SSM. So a VPC endpoint specifically for SSM, it takes 10 seconds. You have to do it if you want to communicate. This is probably it. You know what? If I already mentioned SSM,
okay, go ahead.
I already mentioned SSM, so I'll say in one sentence. I love SSM mainly for its SSH abilities. So instead of actually SSHing and opening ports and opening IPs, that same thing that I mentioned now to run the command can actually serve you to connect to the instances. If you've ever right-clicked on an instance on Amazon and you notice the connect option, and then in the tabs you have Systems Manager, that's the thing. you add permissions, and if the agent is there and listening, you can just connect to privately held instances without a VPN, a bastion, anything insecure like that. As long as you're authenticated with Amazon, in this case, you can just log in. And by the way, not only in the browser, Amazon have their own plugin for the AWS CLI, so you can do it with the AWS CLI. You type AWS Systems Manager Start Session, if I'm not mistaken, and you're there. You get a shell in the cloud in a private instance. So just try that. Done.
I also like this SSM. So first, for our listeners and our viewers, SSM permissions, like to be even more specific about that, you need to create the proper IAM role and then attach it as like the instance IAM profile role, okay, and then attach to, and only then you can use SSM as Omer mentioned. Okay, so basically read the docs, you'll see all the prerequisites as Omer mentioned, but yeah, it's a caveat, you need to be sure you're doing it.
By the way, as annoying as it is, because it's so annoying, I have an open source tool I wrote, which I should release soon, and that does exactly that. It will add the role, it will create the roles if you don't have it and attach the instance profile. It will add the VPC endpoint if you want it. If you just want, I made a sub command that's called doctor, it will just tell you what happens. Can you communicate? Does it have an agent installed? Stuff like that. So I hope it helps.
It's also good if you're losing the SSH key to the EC2 machine. So let's say if you have a runner and you want to SSH to it, as you said, but you don't have the private key to SSH to the runner. So there you go.
That's an amazing point, by the way. If you lose, that's a solution. But if that starts to be the method, that's the practice, that's how you work. No need for SSH keys. No more. Just no need. You're connected because you're authenticated with the cloud, and this is it. So that's another amazing point you raised.
And also about the cleaning, okay? So I'll even do, again, we like double clicking. So double clicking on the cleaning, okay?
Yeah.
So what I like to do to clean is, at the end of the Docker file, because Docker prune is nice, but you can only prune if you want to prune, like, let's say, labels. So what I do Docker images and then grep and then, check which images have which labels. And then if the label says, let's say, keep equals true. So if a Docker image contains the label keep equals true, I'm not going to prune it, or, the other way around. So if it does contain it or doesn't contain it. So according to that, I'm going to delete images on long-running EC2 runners with Docker. It's not amazing. It's not the perfect solution. It should be in a cron job. But I'm just saying, but if you want to write a cron job, you need to know what to write inside, which command and how to delete. And sometimes you do want to keep Docker images. So Omer, you gotta say something. I see you want to say something.
As you were talking, I had the response, and then I thought, no, wait, he's right, because my response was, okay, yeah, good for you doing that. I just rotate everything. Good for me. I'm more secure or whatever. And then I thought, no, wait, Meir is actually right, because that's why you use Docker, right? The cache thing is not it's not a bug. It's a feature. You enjoy it. No latency. The images are there. You don't have to wait. That's why. Exactly. So. Yeah, it's attention. So you need to find
it only means you don't work with Windows, because telling someone who works with Windows images, just kill the machines, it's killing me. Okay, you cannot say to someone who works with Windows images. I
agree.
Because they are like 7 gigabytes if you install .NET and everything.
So I won't open the debate.
It's crazy.
That's like in one extremity. I do have developers not really familiar enough with Docker, because I don't know, experience, whatever. They build images that can get up to 1.5, 2 gigabytes, Linux images. And that's also bad. And that takes time to download. So you want to avoid these two. Different session, different topic, different discussion. Still, worth mentioning, if you keep lean enough images, like using operating systems like Alpine or even Scratch, if you're running binary loads, then you can keep yourself from that and enjoy the cache and don't have to clean it all the time or rotate the images. That said, I'm still using spot instances and rotating everything, and the hit is fine in the balance with what I'm getting out of it. So that's my go-to.
So I'll take the next topic for the CI/CD runners. I'm just wondering how you do it, okay? So when you build Docker images, specifically Docker images, because you can build also, native applications. So let's say you build a Docker image for cloud applications, which needs to be deployed somewhere in the cloud, Kubernetes, ECS, whatever. So when you build it and you want to save the cache somewhere, so you don't have to build to install each time the npm packages or, yarn packages, how you install those node packages.
Yeah.
How do you cache those things? Do you use the mechanism. If I don't know if GitLab has, because GitHub has a mechanism for caching.
It does.
Okay,
yes.
so do you use the CI/CD mechanism, or do you use maybe Docker cache somehow? I'm just wondering, how do you cache your... Okay, I'll ask it again.
Yeah.
How do you cache your node packages for a web application that is built in Docker or whatever?
Okay, so GitLab has this extension of using cache. It has a few solutions. I'm using S3. All you have to do is configure that in the runner configuration file, and you're telling it to store the cache on S3, and then S3 is used as storage, but you access it with a key. So my key is the name of the project / the branch name to differentiate, right? Because I don't want it to keep cache for everything. So to me, it makes sense to npm install from scratch if you're on the same branch, and then next iteration of the same run, if it's not yet merged, you don't have to keep npm installing stuff, like using the difference. So it will do npm install, but it will use the cache. So my runners, when you do that, are accessing a cache on S3 with their key, fetching the cache using them, using that, and then npm install runs faster. But again, between
and
branches.
the runners are running in a private subnet, right? I guess.
Yes.
So have you added like a VPC endpoint to S3 to
Yes, I
avoid
did.
paying
Of
for a
course.
lot of traffic?
Yeah,
getting out to
not
the
only
internet?
for that, but yes, of course. Again, cache of private libraries, you probably do want to pass them through a VPC endpoint, and safer, faster, everything that comes with it. It costs a little bit, not that bad. Yeah.
Yeah, it costs way less if you do everything through the NAT gateway, right?
For sure. Yes, traffic through NAT is expensive. Yeah.
Okay, and what about, okay, so you have this option. Another option would be, okay, are you ready for it?
Yeah.
You can use the Docker registry, like some Docker registries allow you to store cache actually in your registry. Do you know the command, like when you Docker build, so you can do Docker build cache from? Do you know it?
Yes.
Okay, so
So
let's
that's
say...
built on top of a layer, right? It can fetch a layer and then use the build for that. Yeah.
Yeah. So let's say what you can do, okay, just another example. So either you can use the CI/CD provider cache mechanism, and as you mentioned, if it's backed with S3, you can also add a VPC endpoint and go with that, which is amazing and it's great. And I'm also using GitHub with its own caching mechanism. But if you build an image and you push it to ECR, so to cache it properly, okay, there's no good solution out there currently, okay, like out of the box. So what you can do, if you build your image as a multi-stage image, so let's say the first stage is let's call it the builder. Okay, so the builder does the copy package JSON and yarn lock, whatever, or package lock, and then npm CI, npm install, yarn install. You got all those node packages in the builder. Amazing. Once you do that, you also have the multi-stage, right? So if it's a multi-stage, then the second stage is the app. Okay, and what the app does is after you installed everything, you also, sorry for not many, but also the builder does the npm build. Okay, so you build everything, like everything is done on the builder. So you copy the package lock JSON yarn lock, npm CI, great, then npm build or yarn build. You got the application ready, you got the dist folder ready. Now you got the second stage, which is the app. All you do is copy everything to the app. Like it can be Node Alpine, like a very, very, very slim images that only contains the dist folder and any other file that is necessary with a copy command.
Because that's air quote or already compiled, right? So you have
that's already exactly
transpiled, but it's the artifact.
Exactly. So if you've written it in TypeScript, you already got it in JavaScript. So the dist folder is a pure JavaScript or whatever. Okay, now that you have that, you need to push to ECR those two images. So first what you do, okay, how the mechanism works, which is great, it's cool. You build the builder and then you build the app. Okay, but how you do that? First you do Docker pull the cached builder. Okay, if it doesn't exist, sure, I'm good. If it does, pull it. So you do those two pipes and then true in bash, so it's okay to fail. Same goes for the app, just to see if the cache exists, and then it pulls also the layers and everything. And it really depends on the registry, so ECR allows it. Okay, it's not in every registry.
Okay.
Okay. After that, you do Docker build the cached builder. So you also try to pull it, and then the thing that you pulled, you tag it again with the same tag, the cached builder. And you do cache from the cached builder. So then when you build it, you got everything ready. The node packages, and if the application didn't change, which probably it did, but that's okay. The node packages are there. So it builds the builder, which is great. And then it only builds the application again. And I love it because even though I'm building the application again, it's okay because it means the code changed. If it didn't change, it shouldn't build again. Okay, so that's
how
great.
often do you change the builder?
Rarely. I mean, when you say change, if you add a new package, then the builder will it will burn the cache.
If you remove,
same.
It updates.
Package JSON changed. Yeah. Package JSON changed. Package docs changed. It will burn the image, right?
I see. So use it
So only if
constantly,
the
like
source
across
code.
the
So
board.
Exactly. So only if the SRC folder changed, like actually your code changed, it will install the node packages, which usually takes most of the time because building the node application can take probably, even if it's big, 1 minute, 2 minutes, it's not too much, but installing a lot of packages is crazy. So then after you build the builder, you build the app image, right? And the first time you do Docker build target builder, cache from builder, great. When you build the app, you do Docker build target app, cache from builder, cache from app. So then you might have even the cache from the app if it's already built and blah, blah. I was able to reduce build times from from 10 minutes, 6 minutes to 40 seconds because I only push and pull. And if you only push and pull and you got this, also my runners are in a private VPC, private subnet. So when you access ECR, actually you don't need a private VPC endpoint to ECR actually, because this will only hit ECR. So I'm okay with not having a VPC endpoint to ECR because that will only pull the metadata from ECR. But the actual image, the Docker image from ECR is pulled from S3. And that's also a thing that Amazon says in the docs.
Okay,
so
that's interesting.
You create VPC endpoint to S3 for a private, runners running in a private subnet. Then they pull the images from ECR, which is basically from S3 in the backend.
Okay.
And then everything is super fast when you push and pull because everything is also it's close. It's in the same region.
Let me stop you right there. What you said is super
Shoot.
interesting, and I think it was a little bit hard to listen to. So if you can push maybe just a snippet even to like a gist to GitHub and share it in the comments or in the description below so people can see this double layered cache mechanism and where you pull from.
I will. It's amazing because it works perfectly. I saw a lot of blog posts about it, but nothing is really generic. So I created like a very, very, very generic workflow that you can just, say which Docker file do you use, what's the path to the Docker file, the build context, the build args, everything is very, very generic, just like a GitHub action,
Yeah.
And then you just copy paste it and everything is automatically happening,
Amazing.
The concept, I think the concept is quite understandable. I hope so. So
it was for me. I hope that for everyone else listening, but I think we'll share a little bit of code because sometimes it's hard to follow through your train of thought.
I agree.
Okay. Do you want to recap?
Sure. I'll start with what you said. I think we'll have to split it between us because we talked about so many things.
I can give a quick list of what I said.
Go ahead. No, so go ahead for you first. I think you'll do it better.
So we started about talking everything around CI runners. Where do you deploy them? Do you use shared ones? Do you use one on your infra? I explained why I use mine on the infra and what my reason to do so were. I use GitLab. I use the shared runners. The project is in the description. That's basically it.
That's it?
That's it.
Yeah, nothing else. We talked for 20 minutes. That's it. That was the topic.
Yeah, I mean, we can delve down into the other topics, but that's basically
about SSM, how
Correct.
great it is to SSH with SSM, right? And read the prerequisites before you do.
Yes.
We talked about caching images and Docker images and how
we
to
went
delete them
very
with
deep.
a
We
cron
went
job.
into secure connections without SSH and keys, but the gist of it is talking about CI runners, why you
gist.
mostly want to use them on your infra, and if you want to go into details, just listen to this again and again.
Yeah, and again, we'll publish the thing that I talked about, the the how to build a node application, okay, with a builder and an app.
That would be amazing.
In a CI/CD with ECR. I'll publish it down below. Okay, just right here.
Right there.
That's it, Omer.
Yeah,
It was fun.
it was very fun. So
Yeah,
see you next time, I guess.
Yeah, I hope so. Bye.
Bye.